This is Mr. Alexander, and I want to talk to you about taking the first derivative, which is also known as differentiation. It's differential calculus. So the rule is pretty simple. If I take example D here, I've got f of x equals x to the fourth plus 3x plus 2. The first derivative, also known as f prime of x, well, that equals 4 times 1 is 4x. Subtract 1 from the exponent to the third power, plus, this is x to the first power, so 1 times 3 is 3, and this is going to be x to the 0th power, because 1 minus 1 is 0. This is the first derivative right here. So in general, the rule is going to be if you've got x to the n power, then when you take the first derivative, it's n times x to the n minus 1 power, which is a complicated way of saying take the exponent, multiply it to the coefficient, and then subtract 1 from the exponent. So let me just show you one more that's kind of like that. Part B, f of x is 5x to the fourth minus 4x. So when I take the first derivative, simply 4 times 5 is 20, x to the third minus 4 times 1 is 4, and the x goes away. Now, the only reason that we really are interested in that is so that we can find the gradient. The first derivative tells me the gradient function, so I can find the gradient on any point on the function. So, for instance, in this one, I want to know the gradient at r equals 1. Now you might notice the notation here is a little bit different. This dc dr, that simply says take the first derivative of c with respect to r. It means the same thing as f prime of x. So the process is exactly the same. So dc over dr. Now this is going to be kind of hard to do in its current form. I always like to take that exponent out of the denominator there. So I'm going to keep the 45r. But now I'm going to move that r up into the numerator, and I can do that by changing the exponent to a negative, which is something I can do now. So this is to the first power, so 45 times 1 is just 45, and then r to the 0th power, it just drops out. Negative 3 times 12 is negative 36, r, subtract 1, that's negative 4. I think that looks ugly. I like to rewrite that as 45 minus 36 over r to the 4th, like that. But that's no good. We've got the gradient function here. It's no good unless we're trying to find a gradient. We want to know the gradient at r equals 1. So when r equals 1, I'm just going to plug in a 1 into that function. So 45 minus 36 over 1 to the 4th power. 1 to the 4th power, of course, is just 1. So this is a fancy way of saying what's 45 minus 36? Well, that's just 9. The gradient of this function at r equals 1 is 9. That's what we've done there. Let me find something a little more challenging like this one. There are 2 points on the curve, y equals x to the third minus 6x plus 1. At which the gradient of the curve is negative 3. Find the coordinates of these 2 points. Okay, so here's my curve. Y equals x cubed minus 6x plus 1. I'm trying to find y prime, which is the gradient function, which is the first derivative. 3 times 1 is 3. X to the 3 minus 1 is 2. Minus negative 6 times 1 is just negative 6. X to the 0th power, it's 3x squared minus 6. Now, I know that the gradient of the curve is negative 3, so I'm going to plug in that negative 3 where the gradient belongs, and I'm going to solve for x. So I think I'll add 6 to get 3 equals 3x squared. Divide by 3, 1 equals x squared. Take the square root of both sides. Positive and negative 1 equal x. Now that's all well and good if I'm looking for the x-coordinate, but I'm not. I'm looking for the coordinates of these 2 points. So that's an x and a y. So I know that the two x values are -1 and 1. How do I get the y values? Well, I'm going back to the original function where the curve is, and I'm just plugging in 1 for those. I'm going to let the calculator do it. I'm just going to type in x cubed minus 6x. Should probably show you what I'm doing. Plus 1. Type that into y equals. Now if I go to the table at -1, the y is 6. And at +1, the y is -4. These are the 2 points on this curve where the gradient is equal to -3. Now we can actually see that if I was to graph this thing. Look at those points where x equals -1. That's like right there. You can see it's going down. That's the gradient's -3. It's going down. And at +1, again, it's going down right there. So I'm feeling pretty good about those answers. I'm going to go with that. I'm going to do a few more of these for you. Point Q lies on the curve y equals 2x squared minus x plus 1. The gradient of the curve Q is equal to 9. Find the gradient function. Well, the gradient function is just y prime. That's going to be 2 times 2 is 4x to the first power minus 1 times 1 is just 1. X to the 0th power. That's the gradient function. And B, we're supposed to find the x coordinate of Q. Well, I know that the gradient at Q is -9. Well, here's my gradient function. If I set it equal to -9, I can solve for x here. I'm going to subtract 4x and then add 9. And so x is going to equal -2. And to find the y coordinate there, I'm just going to plug that -2 into the original function. So 2 times -2 squared minus -2 plus 1. That's 4 times 2 is 8. 10, 11. Way you can verify that answer. 2x squared minus x plus 1. I guess I'm going to retype all that. 2x squared minus x plus 1. At x equals -2, the y is 11. Now, I'm going to show you something I didn't show you in class, a nice way to cheat. If you go to math, hit the math button, and scroll down to 8, there's this nice function nderive. If you type in x, and then type our function 2x squared minus x plus 1, and where x equals 2, we should get the gradient is equal to -9. This is a nice way to double check our work. It's 7. That's because it's a -2, not a +2. X equals -2. There it is, -9. That's just a nice way to use the calculator to double check your work. We could have done that on the previous problem as well. Right here, we could have plugged in our two x values. So I'm going to do again, math. 8, type in the function x cubed minus 6x plus 1. And if I evaluate that at x equals -1, well, hopefully I get the gradient is equal to -3, which I do. And at +1, hopefully I get -3 again, which I do. It's a nice way to double check your work. That's math 8 if you want to use that little technique. Just a nice little way to cheat. A little thank you for watching my video. Last one I want to talk about. Consider the function f of x equals 0.75 x squared minus 6 over x, where x does not equal 0. Sketch a graph for the function from -5 to 5. We can let the calculator handle most of this for us. So I'm going to type in this 0.75 x squared minus, in parentheses, 6 over x. And I'm just going to hit the window button because they only want the x's from -5 to 5. So when I hit the graph button here, I just want to make a sketch that looks roughly like this. I want to transport this from my calculator to my paper. So I've got my x, I got my y. I'm going from positive 5 to negative 5, and my y's are from 10 to negative 10. And I know that this thing is just kind of looking like this, and it's kind of looking like that, roughly. Remember, a sketch doesn't have to be perfect. What you do have is two numbers on each scale, or sorry, scale on each axis, so two numbers on the x-axis, two numbers on the y, and then a rough picture of what this thing looks like, which we've got. So I'm supposed to find f of 6, meaning I'm plugging a 6 in for x, 0.75 times 6 squared minus 6 over 6. Well, 6 squared is 36 times 0.75 is 27 minus 1 is 26. Find f prime of x. Before I do that, I want to rewrite f of x a little bit. I want to rewrite it as 0.75 x squared minus 6 times x to the negative 1, because if I leave it like that, that's hard to take the first derivative of. But if I rewrite the exponent as x to the negative first power, that looks like something I can do. So f prime of x is going to be 2 times 7.5, or 0.75, which is 1.5 x to the first power. And now here I'm going to have negative 1 times negative 6 is positive 6x to the negative second power, because negative 1 minus 1 is negative 2. You can leave it written in this form, but I personally think that looks kind of goofy. I like to rewrite that as 1.5x plus 6 over x squared. Technically they're both correct, but this, to me, the problem gave it to you as 6 over x. It just feels nice to end with 6 over x squared. Personal preference. Find the gradient of the graph at x equals negative 2. So, in other words, plugging in negative 2 into the gradient function. So I'm going to do 1.5 times negative 2 plus 6 over negative 2 squared. So that's going to be negative 3 plus 1.5, I think. So that should be negative 1.5. Let me just do it in my calculator because I don't trust my brain. And I always screw up these videos, and I'm trying not to screw it up today. 2 squared. Hey, it's negative 1.5 for that one. Now, again, we can use that math 8 function to double check it. So let's do that. I'm going to the calculator. I'm doing math 8. I'm typing in an x. I'm typing in the function 0.75x squared minus 6 over x. And I'm going to say, hey, what did it say? Find the gradient at the graph where x equals negative 2. Plug in a negative 2, and hopefully it says negative 1.5. Sure enough, it does, so I'm feeling pretty good about that. Alright, that's my intro to differential calculus. Hopefully it was useful. Thank you for watching. Next video will be over calculating the equations of tangents and normals on graphs. See you then.